Hey everybody, welcome to another episode of the program. Today we're going to go over the concept of Aquaterra and all these various sites having to do with the Younger Dryas boundary, the depths of the last ice age, the last glacial maximum, human history, and basically all the capabilities that are now being rethought in terms of human capabilities, what they were able to do in the remote past, and also new insights to the younger generation of archaeologists and researchers and other scientists in terms of what really went on in the prehistory of the Earth. And this article is awesome because, for a number of reasons. One are all these different maps that they have. And two, it kind of sums up a lot of the conventional perspectives that are out there right now in terms of this subject matter of, again, human origins, the science of the earth, paleontology, archaeology, and what's in oceans, and how basically throughout the Pleistocene we saw these glacial and interglacial this pattern where land masses have been submerged and re-emerged, and the whole process behind it and the context of the research and all that stuff is a very comprehensive article that I highly recommend you guys check out. This was on, I think, Discover magazine. Okay. Again, from Doggerland to Beringia, the sea took some of prehistory's most important archaeological sites. There's a continent-sized gap in our knowledge about our collective past that scientists are only now starting to fill in. So, yeah, that about sums up the article here, that it's acknowledging that we don't know much about what happened beyond a certain point in time. And this article goes over all the different spots of now submerged coastal landscapes that were once exposed and accessible to our ancestors at multiple times in prehistory. So that's very important, including key periods of human expansion across the globe. The square mileage of these areas now under the seas is equal to that of modern North America. So again, that's a continent-sized amount of land that once was above water, and it's just hard to believe that humans back in those days when it was above water wouldn't have sought after that land. And that's what this article goes through. It points out that it shouldn't be brushed to the side that humans and other mammals tend to be attracted to the coastline. A lot of people underestimate that fact. And so what this article does partially is hit home the fact that not only are humans and some mammals attracted to the coast, it seems like almost by default that they would go there for various amounts of reasons that we'll go into. This Jeff Bailey, the archaeologist from the University of York, he says some of the areas that would have been most attracted to humans are now underwater, and it's hard to believe that humans wouldn't go to these attractive spots, because it seems like human nature, we have a bunch of stuff going on that often gets overlooked, like human curiosity, ingenuity, the thirst for adventure and survival. It wasn't just survival based either. They must have had enough time to really explore those curiosities, and one of those obviously would be water. And getting across bodies of water. So we'll get into that in a second. So these submerged landscapes, also called Aquaterra, are emerging from beneath the waves. Several projects are underway to reconstruct these ancient worlds and search for evidence that will likely rewrite human history. So that's what this article is going through. So the first members of the genus Homo emerged roughly at the dawn of the Pleistocene, which began about 2.6 million years ago and ended with the final drips of the last great glacial melt about 12,000 years ago, or the Younger Dryas extinction event, or the boundary event, whatever you want to call it. It is essentially the epoch of human evolution. And that is interesting. I didn't really realize that, but yeah, humans, the first members of Homo, really does start at the time of the Pleistocene, and The Pleistocene is basically the epoch of human evolution is how they word it. So 95% of the time that humans have existed, sea levels have been lower than they are now, usually by 130 feet. So again, our high sea level that we live with now is pretty unusual. It's only been this way for 5% of the entire existence of our genus. So, and not only that, at the lowest, they were about 400 feet lower than they are now. So who knows what's even further down there and what's left. So during the Pleistocene, the world seesaw between multiple glacial maxima and interglacial periods, which is what the Holocene is now. It's an interglacial period. Human populations cluster along coastlines. Nearly half of us globally live within an hour of a coast, and our ancestors likely did as well. Yeah, we share the same genes. We have pretty much, when you boil it down, we have the same inclinations in terms of preferences, certain preferences and stuff like that. So we are, although there are a lot of differences between modern man and our ancestors, there are a lot of similarities as well. And one of them definitely is living near the coast. These lost regions are not merely stretches of continental shelf now underwater, but rather resource-rich ecosystems and corridors once used for exploration by early humans. Now, this is going to be the crux of all the arguments here in terms of what we could find in underwater archaeology. There are a ton of techniques that we will go over that identify these resource-rich ecosystems, and also proves that not everything got washed away with the high sea levels. A lot of stuff sticks around, and a lot of it has to do with core samples and all these other mapping techniques that we've developed. So Dobson, he's another scientist involved. If you look at the factors that drove our evolution, the richest sources of the element iodine are found on the coast, which is essential for our thyroids to function. This is a really good point. So fish, seaweed, and shellfish, these are all coastal resources in which iodine, is it iodine or iodine? I think it's both. Iodine is a necessary resource. So we have to have it to survive. We're dependent on it. So that alone means humans would seek those things out. And where are they? They're on the coast. The appeal of coastal living is not just limited to humans. If you look at ecological data for mammals, both herbivores and carnivores occur in greater densities in coastal regions. Again, probably for the same reasons humans do, because of different resources. Glacial maxima typically meant global shifts to a drier climate that could have made inland areas less habitable. So this is also another really often overlooked point, is when glaciers come back and we have this period of glaciation, not only are the coasts now the formerly submerged coast exposed, but living inland is not a good idea because it gets a lot drier, and it's less likely to have the necessary resources for survival. So they're therefore less habitable. So obviously it stands to reason that humans love some level of comfort, and they would seek these coastal regions again for resources and raising families and all that stuff. During periods of lower sea levels, these coastal regions would have been particularly attractive because they generally coincide with periods of greater aridity in the hinterlands, which is again deep inland away from the ocean. Archaeological sites at or near the shoreline as early as the 18th century, that's when they first started recording them, so within 300 years ago. So there wasn't much there wasn't much curiosity, or there wasn't enough rather for scientists in those days to pursue those endeavors for a number of reasons. Few people bothered with underwater exploration of submerged coastal areas because it would have been too difficult with very low prospect of finding anything. And yeah, that does stand to reason because they didn't have LiDAR, they didn't have all these different mapping techniques that we had. It wasn't as sophisticated 300 years ago. So it does make sense. But now, with newer technologies such as LiDAR, bathymetry, which uses laser pulses fired overhead from drones or planes, I talked about that a ton of times, especially with the South America episodes. And then also, these are used on the paleo coastlines, basically Aquaterra, the stuff underwater that used to be a coastline. More projects are partnering with offshore gas and mining exploration companies, piggybacking on their survey expeditions. So this is what's going on now, and this is why there's going to be a sudden upshift in these paleo-coastal explorations. So more and more governments require offshore archaeological assessments when signing off on development projects. A bias remains against the idea that early humans were advanced enough to use coastal resources, but that's probably going to change because of all of what promises to shore up all this new mounting evidence and again, a renewed interest in the subject, especially now that we have the necessary tools and instruments to get those conclusions and follow through on this data that's long overdue, I think. Many younger researchers are more open-minded. Shimona Keeley, an archaeologist from Australian National University, found new evidence for a possible route for early humans to have reached Australia about 65,000 years ago. We'll get back on that into a little bit, but what she said is very interesting, and this is what has failed to be mentioned a lot by the, I guess you can say, legacy archaeologists. So when she was working in Indonesia on an archipelago, what she did was she imagined early human explorers like in their shoes, and those people were coming from a developing culture on an island archipelago where most of that time you can see across to at least one island. So her being there and doing field work made her realize how interconnected the area was. So if you're an explorer and you see an island like within dead reckoning, more likely than not, someone along the line is going to try to get over there. And that is an underestimated realization, but it's so true. It's so likely that they would have, especially if they saw it. And imagine if they go to that island and then they suddenly see another island that became visible, and then they start island hopping, and next thing you know, they're in Australia, which is a huge continent. And that is a very salient point that I think doesn't get mentioned enough. So another part of the research that they're doing is they're trying to understand where they should look, because there's thousands and thousands of miles of landscape and thousands of miles of landscape that's submerged. So one of the things that they do is they look for shellfish in areas that have some chance of preservation. I talked about middens earlier. These are just some of the things that come up when they're looking for the chance or the likelihood of a certain area being occupied by people. And then from there, they can find other things like tools and perhaps DNA, maybe other animals that may have been trying to dig through the scraps that were also there as well. And then they have these cores that they find. After they reconstruct the environment these early explorers would have encountered, they're trying to get to the level where they can predict the landforms and the soil, the ecology. They try to map all that out first before they can start identifying potential archaeological sites. So again, this is a really long process, but they're trying to do it the correct way, because if they do get all this legwork done at first, then down the road there could be a huge burst of all these archaeological sites coming in almost all at once, because all the legwork has been done, all the mapping has been done, and all the theorizing has been done to the point where, again, they can predict where people might have been, where they might have gone, where they ought to have gone, and so on and so forth. So again, they start by developing a customizable digital map from existing seafloor maps, and then they identify a sediment buried beneath the seafloor, And then from there, they take a core sample of it, and then they sample the layers of these really ancient soils that haven't seen the light of day in forever. And then they, which are all called paleosols, this ancient soil. And then they try to look for pollen, microfossils, algae that can indicate climate conditions. And then from there, all this information allows them to perhaps identify what flora, what fauna were present, and then from there they can reconstruct the environment and determine whether it might have been attracted to human hunter-gatherers on the move. So, for example, if they find a plant that's edible to humans in abundance in a certain area that used to be along the coast, then they can calculate whether or not people, namely hunter-gatherers, would have had a likely chance of being there or not. And then they go into shell middens, and basically, I already talked about this. Shell middens are basically a pile that can record a surprising amount of information about coastlines, climates, presence of even small groups of humans, because they may have left behind stone tools, other facts, or other artifacts, and that confirm a human presence. Again, shellfish requires a rudimentary level of processing. You're shelling them, you're eating the fish, and then you're leaving the shell there. And again, that even a small group of people would leave a pile after a little bit. Even if they had been there for a few days, they'll still be a pile. And just for clarification, this is the interior of a shell midden, so you can see how well preserved this thing is after thousands and thousands of years. And again, this is in Saudi Arabia, or in the Red Sea. So we'll get to that in a second. It was very, very interesting stuff. And then the article goes into a timeline. So it starts about 70,000 years ago. So at this time, our ancestors begin leaving Africa and moving into Eurasia. Eurasia about 1.9 million years ago, and then 70,000 plus years ago, there's more waves of dispersal. And then there's the route of crossing the Red Sea. Now, the conventional route here is the traditional northern route, which is through this land corridor here between Egypt and Saudi Arabia. The second southern route, the proposed route, was not considered for a long time because, again, they didn't think that people had the capability of crossing the Red Sea at the time. So, again, conventional thinking went because it would have required crossing a strait about 20 miles wide at its narrowest point. So they just didn't have faith that archaic humans of that time could cross 20 miles of water. So, and then an unrelated genetic analysis of baboons, right, was published. This research, and it showed that the animals managed to cross the Red Sea at least twice in the last 150,000 years. So wait a minute, baboons were able to do it? So what happened? So when they reconstructed the paleo coastline, it showed that at lower sea level, the islands emerged mid-channel. So the widest stretch of open water measured little more than 2 miles. So that means they only had to cover a distance of, instead of 20 miles, to 2 miles, because again, there was islands that emerged and they could island hop. And island hopping is super underrated because as long as you can see with dead reckoning, then our archaic humans could have seen it with dead reckoning, and they definitely would have crossed. And these islands are called the Pharoson Islands. The Pharosons are home to thousands of shell middens. Oh, well, go figure. So the oldest of these middens were created about 7,000 years ago, the ones that they found. And during times of lower sea level, early human explorers leaving Africa may have left these shell middens on their own. So the challenge is now, if they can be found beneath layers of this sediment, then they can provide the evidence for the timing and route of our ancestors' journey out of Africa, and maybe even earlier dispersals than that. No one knows, but no one's really investigated the Pharoson Islands in this depth until now. So it does make sense that if they do find something, it would be there. And And then Australia, we're going back to Australia. So reaching Australia required seafaring skills, no doubt. And even with the redrawn paleocoastal coastline, there still would have been a ton of islands here that they would have had to island hopped. So they did find two types of mammals in the supercontinent, which was, I'm sorry, not the supercontinent, in these group of islands, which are called the Wallacea, the islands of Wallacea, and they found rodents and humans there. Okay, so then 40 years ago, Joseph Birdsell, he comes up with this theory that there were two routes, a northern and southern route, into Australia. And there were two supercontinents at the time. There was the Sunda and Sahul, if you guys can see in this mini map here. So for decades, researchers just focused on the southern route because, again, it seemed like the most direct, basic route. But then the northern route was recently explored by a young archaeologist. And she says that it was probably more likely that they went to the northern route because of modern map technology, reconstructing the paleo environment and the paleocoast. And basically they updated the models of this thing called intervisibility, which is what I was talking about with Dead Reckoning, where early seafarers were able to see from one island to the next. So this idea of intervisibility is now almost fact, or now accepted rather amongst the community because it's been updated and makes a lot of sense back in 2018. And so her research found that the northern route would have been more likely. It would have been easiest to travel by boat about 65,000 years ago. Well, that number 65,000 years ago is a very key number because there was another research that dated thousands of artifacts in northern Australia. And though the materials in that site were also up to 65,000 years old, well, northern Australia is very close to the Wallacea Islands, right? So many researchers believe that humans did not arrive in Australia until about 50,000 years ago. So this pushes the date even further. And then the consensus is now changing as more and more of these sites are being dated using newer, more precise methods. Like a few months ago, I did the video on Australia and the oldest stone monuments ever, and they also date back to around this time, the last human occupation there. So it does make a lot of sense when you look at everything, when you look at all the research from all the fields from a more zoomed out view. When you see everything broadly, you can see that all of this would make sense, and one doesn't necessarily preclude the other. It's way more likely that this is all one continuous migration, and all this evidence links together. And the puzzle pieces are now finally falling in place. There are often very specific features, such as raw materials for stone tools, fresh water, or a good place to ambush animals that help you refine your understanding of targets to hone in on when trying to find some of the traces of our ancestors. And then there are also more. There's carved rock art at multiple onshore sites, stone weirs, fish traps. These are all spotted now with this new technology, this high resolution seafloor maps that the teams are all creating. So it's a very, very interesting thing. And then we go to California at the Channel Islands, Southern California, and there's this new theory that's not even new, but it's a theory that's gaining momentum that improves upon the ice-free corridor theory that's been around forever. And it has to do with the Channel Islands, or they're a big part of it anyway. So if you guys look at here, the red is obviously the paleocoast, and then the gray is what's there now. So the Channel Islands was one big island, and it wasn't that far from the coast of California. And this is just 16,000 years ago. So millennia before the inland Beringia land corridor opened, humans could have followed this paleo coastline by boat. And I think I briefly mentioned this in a really old episode from like a year ago. But this route would have taken them from Asia and Siberia eastward along the coast, the west coast, all the way down to Chile. So again, they proved that this could be possible because they found all these different projectile points and all these tools and knives, all this stuff on the Channel Islands, which would have been very attractive if they were going down this coast on their way to South America. And it would explain the speed at which they got there, because again, suddenly there's a huge genetics breakout in South America at around 18,000 years ago or so. And that does make sense when you look at the ocean differently. So a lot of conventional, not conventional, but I guess legacy, I'm just going to call it legacy thought. They believed that oceans were for archaic people, it was like an impassable boundary, but really it should be thought of as like a superhighway, like a conveyor belt that moves you if you manage to get a good enough raft or vessel, and it'll just move you. The currents will just move you along. And that's when you look at it that way, then this trip from Siberia all the way down to Chile, just along that coast, really does look feasible. So this route would have taken them from Asia to Siberia all the way down to Chile. Todd Brahe, he's one of the archaeologists in charge, believes a coastal route was open at least 16,000 years ago and possibly much earlier. Very interesting. And then more stuff they found on Channel Islands. Multiple paleocoastal sites of 10,000 years or more have been documented. They've identified artifacts at one of the sites that may be 18,000 years old. There's a shallow bay that would have been protected from the Pacific waves that would have destroyed the continental shelf. And because it's been preserved, the rapidly deposited sediments preserve the features such as rivers, estuaries, and have been attractive to humans for sure. So again, all the stuff that they used, all the technology, all the techniques, they're all cutting edge that they used at Channel Islands. So now that they know those methods work, they're going to test them in other locations, which again is going to be very interesting to see what they find out with that. And then there's Doggerland, which I very recently did an episode about, and it's very, very, very compelling here. Prehistoric travelers could have walked from what's now Central Europe to northern Scotland without even seeing a coastline. And this is about 18,000 years ago when it slowly started inundating the area. So it was kind of a slow flood for them, probably up until the Younger Dryas, and then it just shot up. So where the North Sea is now is where Doggerland is, and here's a map, a better map, and then it went from Dogger Hills to Dogger Island over the course of a few thousand years. So here's what they do know. We know fauna was there by a ton. It was a fantastic landscape with freshwater lakes and an abundance of food, immensely productive. So just that alone, there definitely would have been people living there for sure. There's no doubt about it. So because today fishing boats that crisscross the North Sea occasionally harvest clues about the lost land: mammoth tusks, weapons, tools, skull fragments of humans and Neanderthals. And this is all during a period when humans were expanding north and agriculture was replacing hunting and foraging. And still, Doggerland was a crossroads for different cultures. And then they even think that there was some kind of trade network there. And whenever there's a trade network, that means there's cross-cultural interaction. There's a lot going on. There are multiple populations of people. Researchers have traced stone artifacts found all over Europe back to now-submerged rock outcrops, suggesting that the material was transported by humans throughout and beyond Doggerland. So not only were they within their region were they trading, but they were going long distances and trading goods and transporting material. It's very, very interesting, and it's now almost a certainty that they were doing this. Because otherwise, how do you explain all this stuff, that the tusks and skulls and weapons and stuff like that? It's just really, really dumbfounding if you don't understand what you're dealing with, the historical context. So there's been a 5-year project that will wrap up next year in 2020, which basically I talked about in my last episode, which is mapping all the extinct rivers, identifying areas where human habitation was most likely, and then concluding the analysis of all the core samples they found. And basically they're trying to recreate this paleo environment just to see what the heck was going on. And then they found a couple years ago from the same team that the site might have been woodland with large herbivores present. One of the beetle species found fed on their dung. So again, very, very interesting, very compelling evidence there that, again, if you've heard the term where there's smoke, there's fire, then this is definitely smoke, because why would there be this type of dung beetle here if there wasn't any herbivores at all? So it just doesn't make any sense. If there are animals living there, then if there are weapons there, obviously there are people there. And why would there be people there if there wasn't something for them there? And we know that it was a woodland, it was rich in resources, there were freshwater lakes, there was everything that you would need to survive there. So yeah, let me know what you guys think. This has been a very interesting and comprehensive episode. I think this basically sums up the state of archaeology now compared to legacy archaeology. So let me know what you guys think. I think this is a great episode, or a great article to share with someone who's just learning all this stuff. So let me know what you guys think. Read the article and give me your feedback, and I'll talk to you guys later.